Here we have one last example, and we're not going to do anything new. We're going to do the same thing that we just did working with frequency distributions. So what I really encourage you to do is to pause the video and try to do this on your own. Or maybe just do it step by step on your own and then watch the video and see if you have that step right before you move on. It's really important that you're able to do this by yourself to answer homework questions, but also we're going to be doing this on our first project. We're going to be collecting our own data. We're going to be counting chocolate chips and cookies, and we're going to use that data for the number of chocolate chips, and we're actually going to do our own frequency tables, our own graphs, our own calculations with that data. So this is sort of the first step to organizing it. So in this example, these are the points scored by the winning teams in the first 51 Super Bowls. So how many points were scored by the winning teams? We're going to create a frequency table using 6 classes. And then we're also going to find the midpoints, the relative frequency, and the cumulative frequency table pieces as well. And you can find the boundary points too. So let's go through all that. So the first thing I need to do is I need to find my range. So I need my max value and I need my min value. So we got to be really careful here. These numbers look really close. So I'm going to use some colors. So let's see, I'm trying to find my max first. So I see a 35. See another 35. Okay, I see 38. I see 39. Oh, I see a 46. I see a 55. All right, so it looks like 55 is my highest. I'm just going to check one more time. We don't want to make a mistake on something silly like this and then have to redo all of our work. So again, I see that 5. Okay, then I need my min. All right, so I see a 16 so far as my smallest. I see a 14, that's smaller. $17, it looks like 14 is going to be the smallest, but again, let's double check that one more time. I'm looking for anything smaller than 14. Now you can also go ahead and put these in order if you want, and I'll start showing you in a couple of classes how to use the calculator, because the calculator can help you do that. But if you want, you can do that in order. It's going to save you time later on anyway. So 14 looks like the smallest. Okay. So for my range, I'm going to go ahead and subtract here. So I'm going to take that 55. And I'm going to go ahead and subtract 14. And I get 41. And then I need to find my class width. Now, I know my range is 41. And the number of classes I want, again, you can choose this. They're going to tell us here so that we're a little bit more consistent with each other. But really, that would be the researcher's choice. And they would choose something that they think is the best for the data. If you notice the data is pretty close together, then you're going to choose probably less classes. If you notice the data is pretty far out, you may choose more classes. So it kind of depends. We're going to use 6 classes here. If I do 41 divided by 6, I get about 6.83. So I'm going to use 7 as my class width. So now we're going to start. I'm going to write my classes, and I'm going to write my frequency. Actually, I'm going to do my tally first. Let's do that first. Tally, then I'll do my frequency. Now for your classes, you don't have to start with the minimum value, although we do a lot of times. So I will start with 14 here. If you do something different, we usually do it because it's a nice number. So I could start with 10, although it looks kind of small. So I'm going to just stick with 14. And my class width is 7. So to find my other lower class limits, I'm going to add 7 each time. So I have 21, 28. Now, again, if you're having trouble doing this, just do it in calculator. So I take the 14, I add 7. Oops, that's not 7. 14 plus 7. And then I add 7 again. Then I add 7 again. And I just keep adding 7 until I get the number of classes that I want. So let's say I have 1, 2, 3, 4, 5, 6. So that gives me my 6 classes. And then for my upper limits, I'm just going to take one less than what's here. So instead of 21, I'm going to use 20. Instead of 28, I'll use 27. Here I'll use 34. 42, so I'll use 41. Here's 49, so I'll use 48. And again, these should also be going by 7, so it's a good way to kind of check to make sure you haven't made a mistake. And you can take that last one and just add 7, and that will complete it for you. Nope. Yeah, that doesn't look right. 48 plus 7. Sorry, 55. That looks better. Okay. Now, the next thing I'm going to do before I move on is make sure all my values are accounted for. And that's kind of why I said something didn't look right. I knew I added wrong because my highest value is 55. That needs to fit here somewhere. So if this was a 53, potentially I did something wrong, or maybe I should make my class width a 6 instead. So you can tweak. If you find that it's not working out, you can tweak a little bit. This is really a guideline. So 55 is there, 14 is there. I know I don't see any extra classes. Like I don't want a class that's 56 to what, 73 or whatever it is. That's just extra. So I only want to stay within my data. And now I'm going to go ahead and I'm going to zoom out. And again, this is a good time for you to pause the video, and I'm just going to tally where all these values occur. I have 51 points here, so it's going to take me a little bit of time. So I'll start it, then I'll kind of pause the video and jump to the end again. So go ahead and try along with me. So I'm going to start with the number 35. So 35 goes in this row right here, 35 to 41. Then I have 33, which goes here, 16 here, 23, another 16. So 24 fits between 21 and 27. 14 fits between 14 and 20. Again, 24 fits here. 16. All right, 21 fits here. 32. 27. 35. Let's see, 31. 27. 26. 27 again. I'm going to pause the video at this point and do the last 2 rows and come back in. Okay, so I finished my counts, and what I got for total in the first class was 8, 15, 14, 7, 4, and 3, which does add up to 51. Now, when you're adding up to 51, that is a good check to make sure you didn't miss something, but it still doesn't mean you made a mistake. So if you notice here, even myself, when I first counted, I had an extra number here in the first class, and then I caught it. I caught that I had put it in the wrong class by accident. So I was able to fix it, but just be careful. So double check as you're going through. And again, it may even help to put that data in order. So although it takes some time to do that, it will help your counts be much faster. So you should have 8, 15, 14, 7, 4, and 3 for your totals. So that's your basic frequency table. We can also find other values here. So actually, before I do the midpoint, I'm going to do the cumulative frequency first because that's the easiest. So you're starting with 8 in the first row. And then for the second row, you have 8 plus 15. So you're looking at 23. And then for the third row, you have 8 plus 15 plus 14. So now you're at 37. And then for the fourth row, you have 8, 15, 14 plus 7. So you're at 44. Then you add in a 4, which brings you up to 48. And then you go ahead and add 3, which brings you to 51. And again, your cumulative should match your total at the end. So we get that cumulative frequency that way. Now for your relative frequency, you're taking your frequency and you're dividing it by that total. So we're going to do 8 divided by 51. Here we're going to do 15 divided by 51. 14 divided by 51. 7 divided by 51. 4 divided by 51, and 3 divided by 51. Now, you definitely want to use your calculator here. So feel free to use your calculator throughout this course. Please, please do. So if I just type in 8 divided by 51, I get about 0.1568, etc. So we're going to round this. Your book, looking at the answers. So this is a try it yourself question. They have the answers in the back of the book. So they're using 4 decimal places here. So they're using about, I was going to use an equal sign, but I guess it is approximate, 0.1569. And then I would do the same thing for the next one. So again, you're getting about, we're rounding here, 2941. So I'm rounding to 4 decimal places in this case. And then your other values are going to be 0.2745, 0.1373, 0.0784, and 0.0588. And again, you should get a sum that is 1, or that is about 1. So again, if you're slightly off, like if you get 0.9999, you're probably okay. You may just have a rounding error or something there, but it should be at 1. Usually we use the decimal form. If you're using a percent form, then it works the same way. You're just multiplying everything by 100 to get that percent. So this would be 15.69%, 29.41%, 27.45%, and so on. Again, it's not used as commonly, at least in stats. I think in the real world we use percents more than we use the decimal form. But it's the same idea. You just multiply by 100 and then your sum would be 100%. So occasionally we do see percents instead of the decimal equivalent. Now the other thing you can find would be your midpoint. So you're taking the values within the class. So at 14 and 20, you're adding them and you're dividing by 2 there, and you should get 17. Here you're taking that 21 and that 27, adding them and dividing by 2, and you should get 24. Here, 28 plus 34 divided by 2 should give you 31, and so on. Next, you're going to get 38, 45, and then here, 52. Now, the last thing you would calculate too would be those boundary points. So again, you're going in between the classes here. So you're looking at that 20 to 21 group. So you have a gap there of 1, right? So you're finding the halfway point between that gap. So what you can do there is take that 20 plus 21 and divide it by 2. And what you're going to get is a 20.5. And then for the next group, again, you're looking at that gap. So 27 goes to 28. There's a gap there. And you'd get 27.5. And then similar for the others, 34.5, 41.5, 48.5. Keep in mind there are boundary points on the ends. So looking at that pattern, going upwards, we're adding a half to the upper limit each time. So our upper boundary point would be 55.5. And then going down, we're subtracting a half from each of those lower boundary points. So here we'd have 13.5. Now I know this is a little bit rough, so a lot of times we could just create another column here for our boundary points as well, although I'm running out of some room. But we're just finding those values in between, and we're going to use those boundary points and those midpoints much more when we do graphing next.